Welcome back. All right, let's finish up section 3. So, detection, that's a great way that we can try to deal with tsunamis. Another way will be structural control. Obviously, you want warnings in place first, so that way, if anyone is in the way, you give them enough time to get out of the way. What about all the stuff that's still in the way, like structures? Well, structural control deals with, when dealing with tsunamis, starts with building designs. Houses and small buildings unable to withstand even 1 to 2 meter waves. But larger structures can be engineered in a way to greatly reduce or minimize destruction. So, how do we, when we build these things, think about that and to be able to deal with these structures, be able to deal with tsunamis. For example, in the U.S., in Hawaii has special requirements in tsunami zones. So near the shore, there's special building requirements. But most areas still do not have adequate codes. And that's throughout the world. So designing buildings differently, but also constructing something called seawalls. These are 2 great ways to have structural control about what a tsunami will do. The purpose of a seawall is to not allow the tsunami to move inland. It's a big wall. But now you're building a big giant wall and hoping it will hold the whole ocean back. It's kind of a hard deal to do. But they work in some instances. But if you do make one of these seawalls, how high? Plus, again, they give you a false sense of security. So you're trying to hold back, the whole ocean from rising up and coming in on land. So they give you a false sense of security. Oh, we'll be safe behind this giant wall. Well, what if that giant wall fails? What if the tsunami is bigger than the giant wall, as we saw in that opening image of Miyako? So structural design, to touch on that. So you can see this building is made with tsunamis in the mind. Heavy duty foundation. Everything is raised up. So a number of feet or a number of meters above the ground. So that's at least 20 feet above the ground or so, and then looks like maybe another 20 feet above the beach. So a tsunami that's like less than 40 feet, this might still be okay. That might still be okay. What about houses, though? So houses are pretty susceptible. You can't, unless you're overbuilding a house, that's going to cost you a lot of money to make it structurally sound enough for it to withstand a tsunami. But I found this, and I thought it was kind of interesting. So kind of a cool modern design, industrial design for this house. The bottom floor, again, heavy pillars. Maybe not much going on down here. It looks like the majority of where you would live would be kind of on the upstairs. But the way this is built is kind of interesting. The way it's built. So the way this is built is that, part of this structure is kind of below the surface, and this whole structure actually floats. So that in a flooding event, or like a tsunami, it would actually raise up and kind of float. It would kind of float, so it's not just submerged under floodwater, or a tsunami in this case. But then my question is, well, what if the floodwater or tsunami is so high that it just kind of floats up and then out, and then now your house is just floating on the ocean? It's something interesting to think about. I don't think it'll work all that well with a major tsunami, but at least they're giving it a try. Maybe small tsunamis, small floods. So structurally designing things, keeping building design in mind, but also building something called seawalls. So this is a seawall in Japan. I'm not sure what this says, but there's an exclamation point on the end. Maybe tsunami, go away. But you can see how large of a wall this is compared to this person. Some of them can reach 40, 50 feet high, which this is probably kind of pushing about 50 feet high. It's kind of built on purpose with this curve to kind of absorb some of that energy from the tsunami as it's kind of rushing in. But again, what if it fails? What if the tsunami is higher than whatever this is? That's kind of what happened. So here's an example of a seawall in Miyako, going back to the first image of the PowerPoint, the lecture, where the seawall, well, it was supposed to be through here, but you can see it was just devastated. Just devastated. So here's that very same kind of image from the front, the first slide of the lecture. So again, March of 2011, magnitude 9.0 plus earthquake, mega thrust event happened offshore of Japan, creating a tsunami. Waves of the tsunami crashed over the seawall onto a street in Miyako. So the seawall is here, the thing that's supposed to hold the whole ocean back. Well, the whole ocean went over it. You can, from the same event in different cities along Japan, a whole giant ship was washed onto the streets of a Japanese city by that very same tsunami. And you can see the destruction. I mean, pretty much everything is destroyed. You know, maybe houses here and there, but, you know, they look for the most part, they probably got to be ripped down anyway. Where a seawall was, again, all from the same event, all in Japan, where a seawall was, what is left? You can see the tsunami just tore it all up. Since then, new huge seawalls have been installed, and, quote, it feels like we're in jail, even though we haven't done anything bad. So you have, you know, this large seawall. It does. It's very prison-esque. Again, here you see some residential houses and commercial buildings near a seawall rebuilt in Miyako. I don't know. That just doesn't look sturdy to me. That just looks like a single wall, and if the ocean hit it, it's just going to fall over. Here's another seawall in another city in Japan. It's 12.5 meters high, so about 40 feet high, and it replaced a 4-meter breakwater that was swamped in the disaster. So you went from 4 meters, about 15 feet, to 12.5 meters, 40 feet. But again, what if the tsunami breaks that? What if the water gets through? What if it's so high it goes over? So, what do you do? So if you ever feel a strong earthquake and you're near the shore, wherever you're at, leave the beach right away. Leave any low-lying coastal areas immediately. Get to higher ground. Not up a building. That's not an idea. Like, climb a hill, climb a mountain, if there's one around. If you're at the beach and the ocean all of a sudden starts to recede, to go away, you run the opposite direction. You run from the beach to the higher ground, not to the top of a building. The building may fall down. Try and find a hill or a mountain. The time between kind of these successive tsunami waves, it's not just one rush of water. It's one, and then maybe an hour later, here comes another one, and an hour later, here comes another one. So it can be hours between these waves. So just stay out of any dangerous areas until all clear is given, because even though one comes in and then goes out, an hour later, it could be the same thing again. If you are aware that a tsunami watch or warning has been issued, don't go to the beach to watch the tsunami. Don't go to take some chap snaps and TikToks and take selfies with the tsunami. You're going to die. If and this is the last resort, if waves are arriving, there's no time to move inland to a hill or mountain, then you seek a high and strong building, top floor or rooftop. So a nice big like office building, not a house. But that's last resort. All right. And if all fails, climb a tree, a really tall, strong tree. I guess this is my best suggestion. It's still probably not going to work. If trapped in the water and swept away, look for something to use as a raft, because the water comes in, but it also comes out. And so a lot of deaths come from the water rushing in, but also when people are also, if they're surviving that initial kind of water coming in, then that water comes back out. And so people can get pulled out to the ocean and drown that way as well. These are kind of peppered throughout Japan. So this is a stone tablet in the city in Japan. It warns residents not to build homes below it, because these are called tsunami stones. So it's basically saying, if you want to build a home, build anything above it, because tsunamis probably won't get here. Anything below it, you might get a tsunami. So there's hundreds of these stones that dot the coast of Japan. So I mean, tsunamis have been happening, and there are people 600 years ago. These are 6 centuries old. Kind of put these to say, hey, don't build any houses below this. But guess what people are doing? Building houses below this. Not much good can come from tsunamis. They are a very dangerous hazard, a very real hazard, and they happen all the time. And if you're at a beach, if you're 6 feet tall and you're facing a 15 meter That's about 45-foot tsunami. Yeah, there's not much you're going to do. It's pretty much all over. You know how you can avoid tsunamis? Don't live near the ocean. Arizona, we don't really get tsunamis here. You know why? Because we're not near the ocean. That's the end, my friends. With that, I say goodbye. Ruminate on all this information about tsunamis. We will utilize it in throughout the week when we look at different assignments and activities and labs based on tsunamis. I'll see you then.